We are going to learn about reference angles today. So when we were doing the trig functions, given the diagram earlier this week, and you were dropping a perpendicular down to the x-axis and using that as a reference, well, that angle right there, that's what they call a reference angle. So what a reference angle is, by definition, is an acute angle. So a couple things I want to point out here. It's an acute angle, so the angle is going to be less than 90 degrees, and it always lies between the terminal side of theta and the x-axis. So whenever you are looking for your angle, the two rays that make up the angle are the terminal side of theta and the x-axis. It doesn't matter the direction of the angle. It doesn't matter how big it is. It just really matters where it lands. So our reference angles are always positive because we're just using it as a reference. And we don't care about the direction, and we only care about the size. So I will show you a couple examples. First, I just want to show you, depending on where the terminal side of theta is, where the reference angle would be sitting. So if your terminal side of theta is in quadrant 1, then technically you don't even need a reference angle. Then this is your reference angle. They refer to your reference angle as theta prime. Theta being the original angle, theta prime being the reference angle. But if your original angle maybe spiraled around here a couple times, we would not really worry about how many rotations. We would just want to know what the size of this little portion of it here was. So between the terminal side of theta, which is right here, and your x-axis, which is right here. So it doesn't matter how big the angle is, and it doesn't even matter the direction. Like I could have gone backward and it landed right here. You're just looking for the size of this little chunk right here. When we build our unit circle, then you guys will understand why and where reference angles come into play. So for this one here, if your angle is in quadrant 2, so it is built from the terminal side of theta, which is this guy right here, and the x-axis, which is this one right here. So your theta prime, or your reference angle, is going to be this guy right here. So we would just want to know the size of this right here. If your angle lands in quadrant 3, no matter if it went clockwise or counterclockwise, if it lands in quadrant 3, then the reference angle is between the terminal side of theta, which is right here, and the x-axis, which is right here. So this would be theta prime. That would be the reference angle. So we want to know the size of this portion right here. And then lastly, if your terminal side of theta lands in quadrant 4, terminal side of theta, sorry, no, this is terminal side of theta, x-axis, this is theta prime. So we would want to know the size, want to know the size of this portion right here. So it's always between the terminal side of theta and the x-axis. Do not draw it from the terminal side of theta to the y-axis. That's a common mistake when the terminal side of theta is in quadrant 3. A common mistake I've always seen is that students will want to like find this angle right here for some reason, but that's not right. It always has to be with the x-axis, not the y-axis. So here are a couple examples. So first off, you always want to kind of like keep the integrity of the problem. So if your angle measure is given in degree, then your answer needs to be given in degree. If your angle measure is given in radians, then your answer needs to be given in radians. So for this one, if you just want to mark where theta prime would be, so the terminal side of theta right here, x-axis right here. So right here is what we're looking for. We're looking for the size of that. So all you have to do is do a subtraction here, because you know from here to here is 180 degrees if I go this section right here. So if you just do 205 minus 180, that will give you the size of the reference angle, which is 25 degrees. So it's really just a simple subtraction. This one here, so this is an example. It's, landing in the same quadrant as this first example did, but they're giving our angle measure as this negative measure. And like I said, we don't care about the direction. We just care about the size. So if you know the size of this right here, then you should know the size of theta prime. So your theta prime is right here. So it's the terminal side of theta right here, x-axis right here. Well, we know that if we go halfway around like that, that's going to give us 180 degrees. So this right here is going to be 30 degrees. Right here is an example where we have one that has multiple rotations. So we first want to identify where theta prime would be. So it's the terminal side of theta, which is right here, x-axis, which is right here. So this chunk right here is what we're interested in. This would be our theta prime. Sorry, you probably can't see that well. So what we need to do is just find the size of this right here. Well, if we take our 440, and like I said, we don't care about the direction, so I'm just going to use it as a positive number. So 440, that's how big this section is. So if I subtract off, I'm sorry, this section is one rotation. So if I subtract off this, what I've just outlined in yellow, if I subtract out that rotation, then that's going to give me 80, and that will be the size of this right here that I have not traced over. So this theta prime is 80 degrees. All right, here are a couple examples where we have our theta given in radians. So for some of you, it may be easier to convert this to degrees and then convert your answer back. I would try, though, to force yourself to work in radians just because you're not going to get good at it if you don't work on it. So for this one here, my theta prime is going to be right here because it's the terminal side of theta, the x-axis. So we're looking for this little chunk right here. So as you can see, if I did one full rotation but subtracted out this red angle, that would give me the size of the green angle. So I'm going to take one full rotation, 2 pi, subtract out the angle that they gave us. So you want to make sure you find a common denominator. So 2 pi is really just 8 pi over 4 minus 7 pi over 4. So 8 minus 7 is 1. So the reference angle is just pi over 4. Like I said, if you need to put it into degree, you have to make sure you put it back into radians when you're done because your answer has to be in the same type of measurements. Okay, here's another one where they've given us a negative angle. But when they give us negatives, we don't worry about it if we're looking for the reference. We just know the size of this red arrow here is 16 pi over 9. And theta prime, my reference angle, is going to be between these two blue rays, terminal side of theta, x-axis. So right here's theta prime. So again, it's just if you take the whole circle or a full rotation, subtract out the size of this guy, find your common denominator. So 2 pi is really 18 pi over 9 minus 16 pi over 9. 18 minus 16 will give me 2. So it's 2 pi over 9. oops, sorry, last example. So this one here, terminal side of theta, x-axis. So this section here, this is our theta prime. So for this one, what I would do is I would take the whole angle, the size of the whole angle they've given us, 10 pi over 9, and subtract out this much of it. So 180 degrees, I would take that off. But it's not a degree, it's in radians. So 180 degrees is simply pi radians. So you just do 10 pi over 9 minus 9 pi over 9, because that's still just pi. 10 minus 9 is 1, so pi over 9 is what our theta prime is. And that's it. Let me know if you have questions. See ya.